Hello my dear students, welcome to IMS Academy foundation course on network theory subject. So today we are going to discuss regarding network elements part 3. So in the last week we have covered regarding network theory subject 2 sessions regarding foundation course. Okay, whoever attended those sessions in live or whoever watched those sessions, you people can comment in the comment section, right? In the chat section you people can respond, whoever watched or attended the live sessions of last 2 sessions. Okay, so due to any reason whoever couldn't watch those sessions, okay, kindly watch all those sessions in your free time, right? So this particular subject is common for 3 branches: EC, electrical and instrumentation. So all of you kindly share this video link with all of your friends so that they also will get benefited from this particular session. Okay. So whoever watching our YouTube channel very first time, okay, so all of you subscribe our YouTube channel, IMS GATE Academy YouTube channel, and then click on bell icon so that you will get instant notification whenever the upcoming videos or upcoming live sessions are there. You will get the notification so that you won't miss even single video. Okay, right. So before going to start today's session, I'm going to give 2 important updates. So the first important update is regarding our Telegram channel. Whoever not yet joined our Telegram channel, so kindly join our IMS GATE Academy Telegram channel. Regarding this particular link already provided in the description of this particular video. Okay, so whoever joining this particular Telegram channel, see all these things you are getting for free. Okay, it is free for everyone, anyone can join. Okay, yeah, good evening Matan. So whenever, say for example, currently one live session is happening regarding GATE foundation course on network theory subject. Similarly, whenever the upcoming live sessions are there at our YouTube channel, right? So all the timetables or updates you will be getting in this particular Telegram channel. Okay, and whatever faculty might have written on the digital board during the class, this particular notes we will be sharing in the PDF form right after the class over in this particular Telegram channel. Okay, and not only that, when we will be sharing whenever we are conducting webinar or seminar, you will get all the updates and even job notification updates also you will be getting in our Telegram channel. Okay, on daily basis our faculties will post one quiz question so that you people can actively participate and you can check your knowledge and you can check your confidence. The very next day our faculty will provide the solution for the previous question. Okay, so in this way you are getting one opportunity. On daily basis you are learning one quiz question. Okay, so this is very much important. Whoever studying BTech or whoever targeting GATE or any other competitive exam, so for all of them it will be useful. So kindly share this valuable information with all of your friends. Okay, right. And one more important update. So here at our IMS GATE Academy we are having live online program for whoever aspiring to write the GATE exam in the upcoming years like 2025 or 2026. Okay, so yeah, so whoever interested, okay, to register for live online program at our IMS GATE Academy, so you people can contact to any of these 2 numbers, or even regarding free counseling session, the link also provided in the description of this particular video. You people can book the free counseling session. Our counselors will discuss in detail regarding live online program at our IMS GATE Academy that we are offering. Okay, so for the timing I will discuss in brief, okay, regarding the program features of live online program at our IMS GATE Academy. Whoever enrolling for live online program, all the students are getting 800 plus hours of live online classes. In each and every class our faculties will discuss the concepts from very basic level to the application level, and for like whoever attending our classes, okay, whatever the concepts faculties are discussing, in order to get better understanding, we will be discussing for every concept. We will be discussing the variety of questions, practice questions and GATE questions as well. So with the help of classes you are getting command over the concepts and method of solving. Okay, and in addition to that we are providing theory book for every subject. We are providing the theory book and then we are providing exercise book. Okay, so in the exercise book for all the subjects together you are having 4000 plus practice questions. Okay, whoever practicing these exercise book questions, they will get good command over the concepts, and they can check whatever the concepts they are learning or whatever problems or method of solving they are learning in the classes. That is like theory you can consider. While you are solving the questions from exercise book, this one you can consider like practical. Okay, and whoever getting like after solving any exercise book question, okay, if they are getting some doubt or if they are unable to solve any question, they can refer the solution provided later, okay, in that particular book. In that way, whoever solving exercise book questions, definitely they will be getting good confidence whatever the concepts you have learned in during the classes. And in addition to that, here at our IMS GATE Academy, we are providing the last 34 plus years GATE question bank. Okay, this is one of the very special regarding our GATE question bank. Okay, so here wherever required, we have provided more than one solution, so that whoever like after getting the knowledge from the classes and after practicing the good number of exercise book questions, and in order to get better understanding, and in order to especially for the GATE questions, what kind of questions will be there in the GATE exam and how to solve. Okay, so for that we are providing the last 34 plus years GATE question bank. So for whichever question wherever required, we have provided the alternate solution, so that each and every student get maximum benefit by referring our GATE question bank. And not but not the least, for whatever typical questions are there in the GATE exam, for those typical questions our faculties have provided even video solution. Just you have to open the QR scanner in your mobile, and wherever QR code is present in the solution part, okay, so just scan that QR code, then the respective video will be played. In this way you are getting maximum benefit by referring our GATE question bank. Okay, and in addition to that, at our IMS GATE Academy, we are providing 130 plus various online tests. Whoever attempting these tests, they can check their confidence and improvement, especially whoever doing the silly mistake or whoever facing some challenge, especially the given time, how to effectively manage the given time. For that these tests will be helping. Okay, and then we are providing 12 MyPlan sessions for all the enrolled students of our IMS GATE Academy. We are providing 12 MyPlan sessions. So on an average, every month, each and every student, they can book one MyPlan session with the corresponding mentor, and they can get the proper study plan and guidance regarding their GATE preparation. In this way, whatever required for all the aspirants for GATE 25-26, here at our IMS GATE Academy, we are providing each and everything. Now it is your time. You can think and you can take the decision. So you people can contact to any of these two numbers. Okay, right. So I hope all of you are eagerly waiting for the session. So let us start. Yeah. So before going to start today's session, whatever we have covered in the last session, I'm just giving the brief. Okay. In the last class, we have discussed example questions. In that example questions, I have given the VA characteristics of a particular element. From that VA characteristics, we have identified whether the given element is active or passive, linear or non-linear, or or bilateral or unilateral, etc. Okay, and then we have started the passive elements. So in the last class, we have introduced one of the passive element, that is resistor. With respect to resistor, we have discussed the Ohm's law with respect to the relation between voltage and current, and then we have discussed with respect to resistor, with respect to energy dissipation and with respect to power dissipation. Okay, all the formulas we have discussed. Okay, and then we have discussed some interesting questions as well. Okay, so at the end of that particular session, I have given one homework question. Whoever watched that session and how many of you tried that homework question, so all of you can respond in the chat. This is the question I have given as a homework, right? Whoever tried this question, you people can mention your answer in the chat. This is the homework question that I have given in the last session. Or whoever attending very first time, no issue at all. Now all you people can read the question and you can choose whatever the options you feel correct. This is the MCQ question. That means only one option will be correct. If it is MSQ, either one option or more than one option can be correct. But this is MCQ. Whatever the 4 choices you are having, among 4 choices, only one option will be correct. All of you give it a try. Yeah, first of all, read the question. If a wire having R equal to 0 ohm, that means what? It is an ideal wire. Okay, it is not having any resistance. Okay, so if a wire having R equal to 0 ohm is connected between two nodes, then whose node voltages are same, okay, whose node voltages are same, then its equivalent circuit can be represented as, okay. See, just you can observe here. Okay, you are having two nodes, okay, but the node voltages are same. Whose node voltages are same? Okay, between those two nodes I have connected one wire, and that wire is having internal resistance, or the resistance of that wire is 0 ohm. Okay, right. Now, because now this particular equivalent circuit, okay, they are asking. See, you can observe you are having two nodes, and between that I have just connected with the help of one wire. So, because I have shorted these two nodes, accordingly we can call it as short circuit. Okay, and here whatever the resistor of this particular wire, it is 0 ohm. Okay, 0 ohm, right. Now whenever you are having a wire, which exists between two nodes, and because the end voltages are same, because of that we can call it as short circuit. Now coming to the current, see, in the earlier class, okay, we have discussed one question, but in that question we are having R value not equal 0. Okay, if you are having R value not equal 0, suppose, in that case what will happen? I equal to V by R. The moment if V is 0, see, the difference of these two node voltages is 0, then what will happen? 0 by R is nothing but 0 ampere. So, whenever the resistance value other than equal to 0 ohm, that time if the end voltage is same, because of that the voltage drop across that particular resistor is 0. The moment if the voltage drop is 0, because of that we can represent that equivalent circuit as short circuit. And by using Ohm's law, you are getting 0 ampere. The moment you are getting 0 ampere, so we can represent that one as open circuit. Okay, based on the requirement, while you are doing the simplification of the given network, that time in any resistor, especially the resistor value other than 0 ohm, that means the resistor value is positive, because for all the practical resistors we are having resistor value is positive. So the resistance value other than 0 ohm, okay, for all the cases if the end voltage are same, because of that you can represent as short circuit, and by using Ohm's law you are getting 0 ampere, because of that you can consider as open circuit. Based on the requirement you can consider as short or you can represent as open. But whenever you are having like between two nodes, okay, if the node voltages are same, but between the two nodes you are connecting with one wire, okay, since you are shorting these two nodes, because of that the voltage is 0, you can represent equivalent circuit as short circuit. But in this wire, how much current that can be flowed, that completely depends on the other network elements connected to that particular circuit. Based on that the current flow through this particular wire can vary. Suppose example, due to any reason somehow or other, if the current flow through this particular wire is 0 ampere, then only we can represent as open circuit. Other than that, only we can represent equivalent circuit as short circuit. Okay, now you can observe in option A it is mentioned short circuit. Yes, by default it is correct, but just read option B carefully. Open circuit only if current flows through that wire is 0 ampere. Okay, so that means either A or B. So option C is correct. Okay, because I have clearly mentioned when we will represent open circuit only if current flows through that wire is 0 ampere. Okay, suppose if current flows through that wire is not equal to 0 ampere, in that case we will represent the equivalent circuit as only short circuit. I hope all of you are getting the clarity. Okay, so this is a very important conclusion point. Okay, especially these points will be helpful while you are solving the network simplification or equivalent circuits based on the resistors. Okay, right. Yeah, in this particular session we will discuss the variety of questions based on the equivalent circuits with respect to resistors. Okay, so before going to solve the questions based on resistors, now all of you give a try. This is a simple question based on series connection. All of you give a try. MCQ, so only one option will be correct. I hope all of you are familiar. Yeah, if resistors are connected in series, then we can dash the respective resistances in order to get the equivalent resistance. I hope all of you are very much familiar, right? See, whenever resistors are connected in series current will be same, right? Because of that, if you want to find the equivalent resistance, okay, then whatever the resistances that you have connected, you can add all of them. So that means option A is correct. Option A is correct. Say for example, if there are multiple resistors are there, like say for example n number of resistors are connected in series, then we can add all the resistances, then from there we will get the equivalent resistance. Okay, right. Similarly, now all of you give a try. This is based on parallel connection with respect to resistors, parallel connection. Yeah, just observe, if resistors are connected in parallel, then we can, what operation we have to perform among the respective conductances in order to get the equivalent conductance. Okay, I hope all of you are familiar. See, whenever resistors are connected in series, that time we are adding all the resistances. Okay, so from there you are getting equivalent resistance. Okay, similarly, if you are having multiple resistors which are connected in parallel, that time we have to take reciprocal. Okay, the reciprocal of equivalent resistance is nothing but the reciprocal of each and every resistance. So that sum of all that quantities we have to do. So 1 by R1 plus 1 by R2 plus and so on 1 by Rn. This is the formula applicable for generalized case. When you are having n number of resistors which are connected in parallel, that time just take the reciprocal of each and every resistor value. That means resistance value, just take the reciprocal and then add. This overall is nothing but 1 by R equivalent. Okay, so from here 1 by R equivalent, 1 by resistance is nothing but conductance. So from here you can write G equivalent equal to G1 plus G2 plus and so on Gn. So if the resistors are connected in series, then we can add the respective resistance values, whereas if the resistors are connected in parallel, then we can add the corresponding conductances. So that means here also the answer is option A. So this formula will applicable for generalized case. Okay, suppose if only two resistors are connected in parallel, okay, that time if you want you can consider formula up to here, otherwise from here also you can do the simplification. Okay, suppose I am considering if only two resistors are connected in parallel. Okay, so then we can use this formula. Then 1 by R equivalent equal to 1 by R1 plus 1 by R2. Or if you do further simplification, from there we will get derived formula, directly R equivalent. So here you can take LCM, R1, R2 you will get, and here R1 already present, so R2 will come, plus R2 already present, so R1 will come. So this entire right hand side expression is nothing but 1 by R equivalent. So from here on both the right hand side and left hand side, on both the sides just do the reciprocal. From here you will get R equivalent equal to R1 R2 divided by R1 plus R2. R equivalent equal to R1 R2 by R1 plus R2. So based on your convenience, you can use like this formula or like this formula, especially when you are having two resistors. But when you are having 3 or more than that, that time better you can use the first formula. Okay, after that you can do the corresponding simplification, and then finally you can find the R equivalent. Okay, so I hope all of you are getting the familiarity regarding the equivalent resistances with respect to resistors connected in series connection and resistors connected in parallel connection. Okay, since this is the foundation course, I am going to discuss the variety of questions in today's session with respect to series connection and parallel connection. Okay, right? Yeah, all of you give a try. This is the GATE question which is asked in 2001 in electrical branch for 2 marks. This is a very simple question, but by looking at the question it seems to be like the lengthy question or maybe time consuming question. But once if you understand the given data, and once if you whatever the given data is there, just apply case by case, and from there if you are able to solve the question, okay, then you will feel this question is dead easy question. Okay, in fact you are easily able to get 2 marks. Okay, so that's why whenever you are solving any question in the GATE exam, don't underestimate, because especially when you're having the question is very lengthy. Because of that, sometimes people will think that that is a very tough question. Okay, some questions may be tough, but some questions, okay, if you are able to understand the given data, and once if you are start solving, some questions may be dead easy. Okay, that's why we should not do false conception that directly without reading the question directly we cannot give any conclusion, because sometimes if you are fortunate or lucky, then even the lengthy question you can easily solve, provided if your basics are strong. Okay, so in this particular session, whatever the questions that I am going to discuss with respect to series or parallel, most of the questions are the questions which are asked in the previous GATE years, so that all you people can check your confidence and comment over the equivalent resistance calculation with respect to series and parallel. Okay, all of you can try. See, first of all, read the question. You are having one network like this. Okay, you are having 3 nodes like A, B and C, and here you are having one resistor RA, one resistor RB, another resistor RC. Okay, so this configuration is nothing but star connection. Okay, but anyway we are not discussing star to delta, delta to star in this foundation course. Okay, right. But actually whatever this question is there, with the help of series connection we can easily solve. Okay, how easily we can solve based on series? Just read the question. So from there you will get the clarity. So consider the star network shown in the figure. Consider the star network shown in the figure. The resistance between terminals A and B. The resistor between terminals A and B. Okay, with C terminal open. Now all of you respond. All of you respond. See, there they have mentioned the equivalent resistance. The resistance between terminals A and B with C terminal open. That means when C terminal open, that means whether any current flows through this particular resistor. Now all of you can answer. That's why now whatever the question that we have discussed in the last class, okay, that knowledge is going to help you while solving this particular question. See, physically the resistor is present here, and that resistor value is not equal to 0. You can observe all the 4 choices you can observe regarding RA, RB, RC. you are having the value other than 0 ohm, right? Now based on this one important point, since the C terminal open, that means there is no current flowing in this particular resistor. If there is no current flows through this particular resistor, even though the resistor physically present in the given circuit, but the equivalent circuit you can represent as, now all of you can answer. Regarding this particular part, we already answered in the last class. Even in fact, I have given the recap in this particular session also. Once if you are able to catch that point, then you can solve this question just like that. See, the moment in the C terminal there is no current flows, that means this resistor we can represent as open circuit. The equivalent circuit of this particular part is open. So that means the moment you have removed the resistor RC, now how these two elements are connected? These two elements are connected in series, that's all, right? So regarding series connection, just now we have mentioned whatever the resistors that are connected in series, we can add the respective resistances, right? So RAB is nothing but RA plus RB. RAB equal to RA plus RB, that is nothing but 6 ohm. Okay. Similarly, you can observe between terminals B and C, with terminal A open. So that means now RA resistor you can remove from the circuit. Then between B and C, these two are connected in series, right? So in series we can add the resistors. So RBC equal to RB plus RC. So in this case they have given as 11 ohm. Similarly, you can continue, and between the terminals C and A, okay, with B terminal open, okay, so that means B resistor you can remove. Then between C and A, when you have checked, then RA, RC are connected in series. So between terminals C and A or A and C, any fashion you can write. RCA you can write, or RAC you can write, no problem. RC plus RA is equal to 9 ohm. Now just observe, from the given data we got three equations like this: RA plus RB, RB plus RC, RC plus RA. So that means for the timing I am giving the numbering for every equation. So as of now we got three equations. And how many unknowns are there? RA, RB, RC, three unknowns. Three unknowns are there, three equations are there. Directly can we solve? In general, whenever you are having three equations, and in all the equations if you are having in terms of three variables, then we can easily solve. But here in every equation you are having two unknowns. Okay. Now with the help of these three equations directly you cannot solve. Okay. Now if you want to solve in order to find RA, RB, RC, okay, see, if you want you can verify option by option, that is also one method, okay. Or before doing that one, for the timing I am giving one more approach also, okay. So what you can do, just add all the three. From there you will get one equation in terms of all the three unknowns, okay. So just add all the three equations. So RA, 2 times RA, similarly RB plus RB, 2 times RB, RC plus RC, 2 times RC. So that means I am taking 2 as common. 2 into RA plus RB plus RC, which is equal to, now add all the three on the right hand side. 11 plus 9, 20, 20 plus 16, 20 plus 6, 26. Okay. So here 2, 13 times. So that means from here we are getting RA plus RB plus RC is equal to 13 ohm. Now I am labeling this equation as 4. Now you can use like equation 1 and 4. From there you can find 1. Similarly 2 and 4, 1 unknown. Similarly 3 and 4, 1 unknown, like that. Okay. Suppose from 1 and 2. From 1 and 2 you can observe RA plus RB is what? 6. RA plus RB is 6. So that means from here you will get RC equal to 13 minus 6. That means 7 ohm. So RC 7 ohm, in which option you are having? Only one option, right? So RC 7 ohm, you got only one option. Now without further solving, just let us give it a try. Okay, say for example, RA is 2, RB is 4. Okay, 2 plus 4, 6. Yes, it is satisfying. Next, RB plus RC. Yes, 4 plus 7, 11. It is satisfying. Similarly, RC plus RA, 7 plus 2, 9. It is satisfying. Okay, like that you can verify option by option. Otherwise, you can subtract one equation from this equation. So like that, for every case, you will get one unknown. Okay, in this way, finally you can choose option B. Option B. Okay, I hope it is clear for everyone. If you are facing any issue or if you are having any doubt, you can mention your query in the chat. I will clarify your doubt. Okay, I hope it is clear for everyone. Okay, now I will show the next question. All of you give a try. This is a question asked in GATE PSU in the year 1992 for 1 mark. So in this circuit you are having, there are so many resistors are there, but in this question they have mentioned all the resistors values is 1 ohm. Each resistance value is 1 ohm. Okay. Now in this question you have to find the current flowing in this particular circuit. Okay, here you are having options like 1 by 15, 2 by 15, and this is 4 by 15. Okay, and then option D is 8 by 15. So first of all, see in the previous question, if you observe, in this question you are getting like R equivalent, right? In a similar way, see somehow or other, whatever this entire resistor network you are having, if you are able to get one single resistor, after that you are having supply voltage, you are having one resistor, and the current flowing to that resistor is I. So you can use Ohm's law. Okay, you can use Ohm's law. So first of all of you give a try. Try to get R equivalent. Try to get R equivalent between these 2 points. Say for example, I am labeling this point as A and this point as B. So all of you try to find out R equivalent first. R equivalent first. Once if you are able to calculate R equivalent, after that you can use Ohm's law. From there you can find the current. Yeah. So first of all, just observe here all the resistance value is 1 ohm. In the given circuit, whatever the resistors you are having, all the resistor values are 1 ohm only. Okay, now just observe, these 2 resistors are contained in parallel. So in parallel, R1 R2 by R1 plus R2. Okay, by using that formula, if both are having same resistor, then you can get half of the like any one resistor value, right? 1 into 1 divided by 1 plus 1, that is nothing but 1 by 2. So from here you are getting 1 by 2 ohms. Okay, now after this resistor and this resistor both are connected in series. So from here you are going to get see these 2 are connected in series, right? So 1 plus 1 by 2. In series we can add the respective resistors. Okay, 1 plus 1 by 2. So that means 3 by 2. 2 plus 1, that is nothing but 3. 3 by 2 units are ohm. Now if you carefully observe, whatever this network you are having, similar part here also you are having. Similar part you are having here. Okay, just now we have calculated this part as 3 by 2. So that means here also you will be getting same thing. We no need to calculate further. Same answer, 3 by 2 ohm. Okay, now if you carefully observe, here you are having one resistor 3 by 2 ohm, and here you are having another resistor 3 by 2 ohm. Now these two are connected in parallel. So from here we can write 3 by 2 ohm in parallel to 3 by 2 ohm. So from here, just like here, 1 parallel to 1 is nothing but 1 by 2. In a similar way, 3 by 2 parallel to 3 by 2 is nothing but 3 by 2 divided by 2. From here you are getting 3 by 4 ohm. 3 by 4 ohm. I hope it is clear. Up to now, whatever we have done is up to here, this entire part. Okay, this entire network equivalent resistance is 3 by 4. Equivalent resistor is 3 by 4. Okay, now this entire network we have replaced with single resistor, and that resistor and this resistor both are connected in series. In series we can add the resistors. So that means you will be getting 1 plus 3 by 4. So that is 4 plus 3 divided by 4, that is nothing but 7 by 4. 7 by 4 units are ohm. Okay, 7 by 4 ohms. Okay, so up to here whatever we have calculated, say for example if you want, I will be labeling here this node as C, and this node suppose I am labeling as E. Okay, between C and E we got 7 by 4 ohm. Okay, so if you want I will be writing here RCE. Okay, similarly if you observe, this entire part, because this part and this part both are same, and for this entire network just now we got 7 by 4. Similarly here also you will be having 7 by 4. Okay. Okay, right. So here you are getting 7 by 4, here also 7 by 4. Now both are connected in parallel. So just like here you can write 7 by 4 in parallel to 7 by 4, that is nothing but 7 by 4 divided by 2, which is nothing but 7 by 8 ohm. 7 by 8 ohm. Now after this what you are having? See, up to here whatever this entire network you are having, you got one single resistor. Okay, that single resistor value is 7 by 8, and that resistor and this resistor both are connected in series. In series we can add the respective resistances. Okay, so R equivalent is nothing but 1 plus 7 by 8. So here 8 is LCM, 8 plus 7. 8 plus 7 is 15 divided by 8, units are ohm. So now this entire circuit we have replaced with one single resistor, that value is 15 by 8 ohm. Okay, now you are having supply voltage 1 volt, that entire supply voltage you are getting across this particular resistor, right? Now you can use Ohm's law, and the current flowing through that resistor is I ampere, right? So now you can use Ohm's law, V equal to I into R equivalent. But in this question they are asking the current flowing in this circuit, right? So that means from here you can write I equal to V by R equivalent, and the supply voltage is 1 volt divided by R equivalent is 15 by 8. R equivalent is 15 by 8. So from here you can write 8 by 15. Since it is current, units will be ampere. So 8 by 15. 8 by 15 means option D is the correct one. Option D is the correct one. So when you look at the given circuit simplification, you may thought that it is very time taking. But once if you analyze, because whatever the given circuit you're having multiple resistors, because all the resistor values are 1 ohm, it is very simple. Because somehow other if you are able to calculate for one section, similar value you are getting for other section. Okay, that is the beauty. But suppose if you are having different resistor values, then definitely it is a time consuming. But in the GATE exam, if you observe the previous GATE questions of any year, okay, especially for network theory subject I am talking, okay, the exam paper setters are so smart regarding network theory subject. Whatever the calculation is there, whatever the calculation is required for finding the equivalent resistance, etc., most of the questions, for most of the questions you can solve or you can find the calculation, okay, you can do the calculation in simpler manner, okay. So that means whatever the calculation required you can do in the mind level, or even if you are using pen and paper also, you will be getting simple calculation. They won't make unnecessarily too much calculation, because GATE exam is such an exam, they are checking your aptitude level, okay, how much you are strong on the logic, how much you are strong on the visualization of the given circuit. Okay, that is the approach they are checking in the GATE exam. That's why unnecessarily they won't make the calculation part so lengthy. Okay, regarding network theory subject, whenever you get chance, you people can check the previous GATE year questions of network theory subject. From there you will be getting like whatever the calculation is there regarding R equivalent or L equivalent, C equivalent, anything. Okay, the calculation part they will be giving very simple, or I can say in order to get the simple values, they will be giving the resistor values or whatever the electrical components you are having in the given circuit, those values they will be framing like that, so that while solving the question you won't take much time. Okay. Yeah, I hope it is clear for everyone regarding this question. With this understanding, all of you give a try for the next question. This is a very interesting question. Whoever good at permutation and combination, you people might have learned that concept from the math subject. Okay, so just all of you read the question here and you can choose the possible combinations, and ultimately like as per the given question what you are supposed to calculate, accordingly all of you give a try. So this is a very interesting question. This is a question asked in GATE EC 2017 for 1 mark. Whatever the questions in this foundation course that we are discussing, those are the basic questions. Okay, and that too, whatever the questions we are solving, the questions were asked in the GATE exam. Okay, now you people whoever just starting GATE preparation for the upcoming years, at least you people are getting, even if you are having basic knowledge of series and parallel, with the help of that, how you are able to solve the GATE questions easily, right? So I am giving the glimpse of that. Okay. So first of all, try to understand. Okay, first read the question carefully and try to understand what the information given and what we are supposed to calculate, because most of the questions, if you are able to understand what the given data and what you are supposed to calculate, then from there you will be getting that what formulas we can apply or how to proceed, etc. Okay, first of all, try to understand what the given data and what we are supposed to calculate. See, just observe, a connection is made consisting of resistance A in series with a parallel combination of resistance B and C. You are having one resistor A that they have connected in series with a parallel combination of resistances B and C. Resistances B and C. Okay, say for example, up to now, whatever after reading these 3 lines or 2.5 lines, okay, whatever the knowledge or whatever the information you understood, okay, for the timing I am representing like this, the equivalent circuit. In this question they haven't given the circuit, but from the given data, if you are able to draw the circuit, that means the visualization. Okay, So then from there you can easily solve. Say for example, earlier two questions, if you observe, they have given some circuit like this. Yes or no? We have solved two circuits like this, right? But in this question they haven't given circuit directly, but they have given the information. From the given information you can draw the circuit, right? Yeah. So here you are having one resistor A, that is I am labeling as RA, which is in series with parallel combination of two resistors like RB and RC. RB and RC. Okay, so for the timing I am labeling this node as 1 and this node as 2. Okay, right. Now just let us continue further. Okay, three resistors of value. Okay, here you are having total three resistors like RA, RB, RC. Okay. Now regarding the resistors, they have mentioned the values 10 ohm, 5 ohm, 2 ohm. Okay, since you are having three resistors, they have given three values like 10 ohm, 5 ohm, 2 ohm. And here the most important thing you can observe here. Consider all possible permutations of the given resistors into the positions A, B and C. Okay. So that means, okay, and identify the configurations. Okay, in one case you have to consider the resistor values in such a way that you have to get the maximum possible overall resistance. That means between the terminal 1 and 2 in one combination. Say for example, see here you are having three resistors like RA, RB, RC. Okay, and here they have given three resistor values like 10 ohm, 5 ohm, 2 ohm. Okay, for one resistor, one resistance value. For another resistor, another resistance value. Like that, you can consider. It's not that RA you have to consider 10, RB 5, RC 2. Not like that. You can do permutation and combination. Okay, you can give one value to this one, another value to RB, another value to RC. Like that, do all the possible combinations and somehow other. Okay, in one configuration you will get between 1 and 2 terminals, you will be getting maximum equivalent resistance. Okay, that one you have to calculate. And one more case is what? You have to get minimum possible overall resistance. Okay, so they are considering that between the terminals 1 and 2, in one case you will get maximum resistance, in another case you may get minimum. And whatever the other combinations you are considering, the equivalent resistance value you may get in between the minimum resistance and the maximum resistance. Okay, right. Now final question is what? You have to calculate the ratio of maximum to minimum values of the resistance. Okay, this is a very interesting question. Okay, say for example, here between the terminals 1 and 2, see just observe RB, RC, these two are contained in parallel. Okay, so parallel means you can write R1, R2 by R1 plus R2, like that. RB into RC divided by RB plus RC. Now this entire resistor, you got one single resistor, equivalent resistor, single. Okay, now that resistor and this resistor both are contained in series. In series we can add the resistors. Okay, so you are getting the equation like this. Okay, now just observe. Here you are allowed to use, say for example, RA you are having. See, this is the overall equation. Suppose I am labeling as A. Okay, otherwise any other numbering you can give. Suppose I will be giving as Roman number 1. Yeah, fine. Now just observe this particular equation. So all of you please confirm regarding my voice, is it clear? Okay, just 1 second. Okay, our team are cross checking, okay, regarding the audio. So all other students also please confirm regarding the audio, is it clear or not? Yeah, I hope it is clear. So what you people can check, like whoever not able to get the clear audio, you people can increase the volume. Just check the settings in the mobile or laptop from where you are watching. Okay, so our team has cross checked, so they told that audio is clear. Okay, right. So here in this equation, okay, just observing this particular equation. So here regarding RA, RB, RC, okay, so 3 unknowns are there, and here 3 known values are there, like 10 ohm, 5 ohm, 2 ohm. Okay, one resistor value you can choose at a time for one resistor, like that you can consider. Okay, now when you consider in all the like that cases, like say for example RA, when you have considered 10 ohm in one case, okay, 5 ohm in another case, 2 ohm in another case, like that when you have considered, now tell me among these 3 resistors, for which value if you are considering for RA, because of that this overall value will get maximum. All of you give a try. It is very simple. See, question is very simple. Here you are having RB into RC plus RB/RC by RB plus RC. You can consider something like RX. Okay. Now you are having RA plus RX. Okay. Now for RA you are having 3 chances. Okay, you can consider 10 ohm, or you can consider 5 ohm, or you can consider 2 ohm. Now in which case you will get this entire equation 1, okay, will be having maximum value. Obviously 10 ohm, yes or no? If you are considering RA equal to 10 ohm, what will happen? 10 plus, suppose for the timing I am labeling this is like RX, okay, you will be getting some value RX, okay. So 10 plus RX you are getting, okay. In another case 5 plus RX you are getting, in another case 2 plus RX you are getting, right. So among all 10 is the maximum, right. So because of that this overall value will get maximum. So this is like trial and error, you can observe. So RA value we have fixed 10. Now among RB/RC, anyway those two are contained in parallel, okay, whatever the 2 resistors are there, that you can consider, no problem. Okay, you can consider RB equal to 5 ohm, RC equal to 2 ohm. Okay, you can consider like this, or if you want you can consider RB equal to 2 ohm, RC equal to 5 ohm, no problem. Because ultimately if you observe, it is like product of 2 resistors, here addition of 2 resistors, right, no issue. Now you can consider this one, and from there whatever the equation you are getting, that is nothing but maximum equivalent resistance, right, maximum equivalent resistance. So R max I am writing R max is equal to RA value is 10 plus 5 into 2 divided by 5 plus 2. So 10 plus 5 2s are 10, 5 2s are 10, divided by 5 plus 2 is 7. So if you do simplification you will get 70 plus 10, that is 80 by 7. Okay, you don't need to do the calculation here, you can keep like this. Okay, so as of now we got R max. Now tell me what value if you consider for RA, because of that this overall equation you will be getting minimum. It is very simple, because we already mentioned for RA equal 10 ohm you are getting maximum. Obviously for RA equal to 2 ohm you will get minimum, right. So here I have considered the case for maximum. Okay, now we are considering the case for minimum. Okay, so in this case RA value should be 2 ohm, so RB RC, okay. So whatever other 2 resistors you are having, like 10 ohm, 5 ohm, you can consider in any order, like 5 ohm, 10 ohm, any order you can consider, no problem. Okay, so in this case similar formula you are having, R min is equal to RA value is 2, then just multiply these two, 10 into 5 and then add those two, 10 plus 5. So in this case you are getting 2 plus 10 into 5 divided by 15. So here 5 3 times. Now if you do further simplification, you are getting denominator is 3, right? 3 2s are 6 plus 10, that is 16. 16 by 3 units are ohm. Okay. Maximum equivalent resistance you are getting this much, and minimum equivalent resistance you are getting this much. Now what is the question? Here you are supposed to calculate the ratio of maximum to minimum values of resistances. Okay, so that means R max by R min they are asking. R max by R min. So whenever they are asking the ratio, you have to read the question carefully, because in some question they can ask the ratio of minimum to maximum, right? So accordingly we have to follow strictly. Okay, right. So R max is 80 by 7. 80 by 7 divided by R min. R min you got 16 by 3, right? 16 by 3. So that means, so I can write it as 3 by 16. 80 by 7 divided by 16 by 3. So divide by 16 by 3 we can write as 3 by 16, both are same. So 16 here 5 times. Okay, so 5 3s are 15 divided by 7. So from here you will get, so 7 2s are 14, then you will be getting 10. So accordingly you will be getting 1 4. Okay. So the value you will be getting 2.14. Okay, because it is a ratio of two resistors, that's why there won't be any units. Okay, if you observe regarding maximum resistance, you are having units ohm. Similarly, minimum resistance, you are having units ohm. But because whenever you are taking the ratio, there won't be any units. Okay. Okay, I hope it is clear for everyone. Now all of you give a try. This is a simple question and last question for today's session. I hope all of you can answer this question easily. Okay, what is the answer? After solving this question, you feel correct among the 4 choices, you people can mention in the chart. Yeah, just observe here, in this question, you are having resistor R, this value how to find out. Okay, in this entire circuit, you can observe, other than this resistor, remaining other resistor values they have given, and here the supply voltage they have given and the current they have given. Okay, just like if you observe one of the like earlier question which we have discussed, there they have given multiple resistors and they have given the supply voltage, they are asking current. Okay, but in this question they have given supply voltage, they have given the current, and they are asking this particular resistor value. Okay, so you can observe here 10 ohm, 10 ohm, these two are connected in parallel. Equivalent resistance you will get 5 ohm. Equivalent resistance you will get 5 ohm. Now here you are getting one single resistor and this resistor and this resistor. How these two are connected? Series. That means this entire configuration you can represent as single resistor, and that value is R plus 5. Now you can use Ohm's law, that's all. You are having one single resistor, across that you are having supply and the current flowing through that also you know. Okay, you can just apply Ohm's law. So here V equal to I into R. Supply voltage in this question they have given 100 volts and supply current is 8 ampere and resistance value. Okay, in this case for the timing I am mentioning as R equivalent. Okay, so R equivalent as R plus 5. So here 4 2 times 4 25. So 25 by 2 is equal to R plus 5. So 25 by 2 is nothing but 12.5. 12.5 minus 5, that is nothing but R value, right? So which is nothing but 7.5. So R value is 7.5 ohm. That means option C is the correct answer. Option C is the correct answer. Okay, so in this way, whatever the questions we have discussed in this particular session, all the questions are asked in the GATE previous years. Now see the beauty of these questions. If you are having the basic knowledge regarding the resistors with respect to series connection, with respect to parallel connection, with the help of those basic formulas, you can easily solve the GATE questions. Okay. Yeah, for the time being, we are stopping here. We'll meet you all in the next session. Okay. So some people are facing some audio issue. Okay, no issue. Okay, so next session we are having on 30th March. Okay, we'll meet you all on that day. Okay, timings will be same 4 to 5. Okay, thank you everyone.